you. Let me know you're fine. So, good evening, and I hope everybody had a wonderful day. It's the beginning of new week, also happy new month. So I would today we'll still continue our introduction to manual testing and to software testing. Likewise, we are taking SDLC and so it's still introduction to software testing. So we are still on the SDLC and STLC. So I'll just be recapping quickly. It's going to be a brief one because I want us to go quickly into what we have to finish up this part, the SDLC and STLC, just for us to know the differences, how they are used, look at the defect management because we mm, my expectation at this stage now is that we need to now be hands-on in terms of preparing our script. So in as much as I've scratched the surface in terms of the script, sorry, please, everyone have to go on mute. Everybody should go on mute, please. So if in as much as I've scratched the surface initially about test script, and also I've given examples in the last class, this time around, we now need to make it hands-on. So I'm looking at how we get today, but give or take by tomorrow, what I expect everybody to come into the class tomorrow is you must have a spreadsheet. That's Excel, download Excel. Have your pen and paper, just your pen and your jotter. And always note that anytime when you're on the field of work, ensure you have an instrument, something like me. Up till now, I still have a Bible. I call it my jotter. But everything I go into a project for, you must be able to jot down something, things that you can remember, things that you can iterate. When you scribble down things, you don't forget it. The tasks you're told to do, make sure you have them written down. It gives you it lets people know that yes, you know what you're doing. You cannot assimilate everything I am saying. That is the reason why we record, so that you can play the record on and on. But if you don't have an avenue where you do recording, we are only doing the stand-up, we are talking in a meeting. Most of the time, you might not record. So the only way you can get things done is to scribble things, write things that this is what he has said. This is my own task. This is what I'm meant to do. Informations that you need. When you put them down, you don't forget them. So anyway, today, I'm just going to go back briefly. Just it's going to be a quick run. We have talked about SDLC and we've talked about different models, pros and cons, the concept of learning. So that takes us to the various models, and these are the various models that we have. It takes us to the continuation of it, which is waterfall and V model. And the three main ones that we use are this: waterfall, V model, iterative incremental development model, which is the agile. Don't forget, it's just a recap of the class. I believe you understand. So this is just a definition of SDLC, software development life cycle. I said it's a process that produces software with the highest quality and low cost in short time possible. So that takes us that I explained the life cycle using what the life cycle is in terms of using a chicken as a life cycle of a chicken as one of example, and I also did one which we human beings as one. So that takes us to a full fact about um, just the common facts that you need to know about SDLC, is software development life cycle, is also called software development process. Likewise, is a framework defining the tasks that each software developers take. So this is the life cycle, is a methodology, so which clearly defines the process for creating high quality software in details. So these are the phases that SDLC go for: requirement analysis, planning, software design, such as architectural design, software development, testing, and deployment. So we take each of them as one, which I explained requirement analysis, design, development, testing, maintenance. If you were not in the class for this, you could just watch the video, you get a full explanation of that. So that takes us to waterfall. The reason for this name and the reason for this model called waterfall is because of the diagram you can see is like a waterfall, which I explained different things there, talked about the design phase, the deployment phases, talked about testing, talked about deployment and maintenance phase. And I said the advantage, which is the pro, is that phases are processed and complete one at a time. So works well for smaller projects where requirements are understood. What is a disadvantage? Complete a stage before moving to the next. If something goes wrong at one stage, there is no chance of going back. This is an expensive model. So that takes us to explanation of each, which I talked about requirement gathering analysis. Um, so we need to understand the proposal, look at what the customers have gotten, then the requirements are being gathered with the information we have from the client, the customer in general. Then that takes us to the next one, which is planning and design. What is the planning and design? This phase is owned by we. We also as testers start, and the team at large, both testing team, development team, BAs, we all start working together at this phase. All this, including requirement gathering, we all start together. So this time around, we start preparing our own plans, test plan, test script, and the likes. So building, this is code, is done by developers. So the developers, everything we have gotten from the requirement and also at the planning and analysis phase, we start implementing it. The developers start implementing it by developing what he understands from the project we want to work on. Then the next phase is testing. Now the code has been written. It's time for us to test. Usually is done in a special environment. So you'll be given an environment where you test and you check bug, you validate the bugs, see if they are working as expected. We use it. So the next one is deployment. Deployment is done once we have the product, we are ready, then it's being deployed to live. To live means the public. Please, everybody can use the application now. Then the final one is maintenance. So what is maintenance? During this phase, the software is maintained so that it stays effective and relevant. So so we just make sure that now we have deployed it. We still need to still get in touch, still be helping them maintain it in terms of that. So this is the phases that we look up for. So that's for waterfall. Now let's take the V model. V model, this is the reason for this is because of the diagram. You can see it's a V shape. So that's the reason for that's the concept behind it. But the only thing here is that at every verification stage, there is a validation. So we've got verification stage, we've got validation phase. Remember, I told you this too, verification, validation. Ensure that you can still remember verification. Are we building the right product? Validation. Are we doing it as the customer intends? Now we are checking what it is. So that's the concept behind it. And we still continue further to say this means it's a single phase. Every single phase in the development cycle, there is direct associated testing phase. So we talked about verification. Are we building the right product? Validation. Are we building the right product? First question. The second thing is that, does it meet the user's need? So those are the questions we ask ourselves. Testing in testing early in the life cycle, thereby enhancing the probability of building an error-free and good quality product. So we've got is a major drawback because once any issue happens at this phase, maybe at this phase, we have to go back and actually change every document, all the artifacts that we have here. So it's a major drawback. That takes us to the iterative part, which is the agile model. Requirements are broken down into multiple standalone models of software development lifecycle. I used this illustration um, in the previous class. So what it means that to every iteration, we have to do a requirement gathering, a requirement um, design, coding, testing, software, product increment. So that's the way it's done every phase, at every phase. So what is an iteration output? Partially delivered product. The process is repeated until the entire product development is completed. The repetition of these processes are called iteration. So that's when can we use it? When we actually need to get the basic functionality delivered fast. So, for example, I gave you an example of a website. You want to deliver a product. Instead of us to wait for the whole product to be delivered, you can be delivering the product in bits and we'll be testing it, including once we go through the phase, we deploy it to the client and they test it also. So those are the things that what is the advantage? It's quick delivery to the market. Customers can provide feedback to each product increment, thus avoiding surprises at the end of development. Requirement changes can be easily accommodated. So what is the disadvantage? It requires effective planning of the iteration. So this takes us to like a diagram just for us to see what we were doing. And that's where I said those phases that we've mentioned, requirement, analysis, design, you do the first iteration, you go to the next iteration till you finish the whole iteration, which are they are sprint basis. And I told you, you in this internship, we all will be working in sprint basis. I explained this diagram also in the last class. Please, if you were not in the class, you can watch the video. I always just like to do a recap so that it will bring you back, because if it was something that we've done a block, I've done it at a stretch, I would have gone straight to the topic of the day. But because there are spaces, I need to bring back your memory to things so that you can follow. That's the essence of me. But it's just a quick overview. I don't want to. So this one is definition of ready. Are we ready to start? Do we all have this is for the whole team. Do we have all the information rested? Yes. Now we put it in this bucket of backlog. This bucket is where we dump everything. We just dump it there. So we start picking it into the next. We open a new bucket, which is a sprint, a different one. We'll pick what we want. Little thing, we don't want it too heavy. We want it just little. So from there, we pick it and put it into the sprint. So sprint, this is what we want to do. Login is what we have for sprint one. From sprint one, we all prepare it. Everybody start preparing. We start laying our testing bed in terms of test prep, do our script, our planning, and make sure everything is ready before before the deployment to test environment. Then the next thing it goes by the developer. He start doing the code. Once the code is completed, it deploys into a test environment. We the testers speak it here, and once it's tested, it goes to the integration team. We look at each of the modules. Are they linking up together? Then it goes to delivery. Who is the delivery? We give it to the customer. Are you happy with it? Yes, we are happy. Then we are done with login. So we take another iteration. This time around, search functionality. We go through the rigor again, but this time around, we don't need to start from ready because we already have it in our bucket. We'll pick it from the backlog to the sprint and we go in that circle. So that takes us, the next thing is just also the same thing I've explained previously is also in this diagram. So, and that takes us to SDLC. This is, the previous one I've talked about was SDLC. And I told you, I still iterate again, is the development team as a whole. But this time around, we are streamlining it to software testing life cycle. So we as tester, what is our life cycle? How do we run our entire process? How do we How does it entail? So these are the things we do. We start with requirement analysis, test planning, test design, environment setup. We start with test execution, and we end up with a test closure report. I linked this same process, to what we did initially, which is the fundamental test process. When we did introduction to software testing, when we talked about the general principles of testing, we talked about the fundamentals of testing. These are the fundamentals of testing, which I did explain also rigorously in the class. So just an acronym, a fact about it is software testing life cycle is different. Both are different. You are going to see the differences at the end of them by the time I finish now. So I'm going to explain the differences. I'll let you say it. So that takes us to what is the role of a software tester? I said it. I said even the most talented, highly team developers still make mistakes. You and I can still make mistakes. A developer can still make mistakes. No matter the testing they do, we still find bug when it's deployed to test environment. So it's not that they are not good at what they do. I told you they are good, but of course that's the reason why we have different teams. Development team, tester. I know how to test. A developer will just do his own bit, but the rest thing is for we testers to validate what the developer has done. The role of a software testing, of the software testing lifecycle, is to identify any mistake that's been made and find solution for them, helping to maintain the quality of every piece of software produced and ensuring that the project requirements are met. That's our job. So now, what are the phases? We've got 6 phases that we're going to look at. We talk about the requirement analysis. We've talked about test planning. We talked about test case development. Then we talked about environment setup, test execution, then test cycle closure. So we'll take it one after the other. So now, this is the activity in requirement gathering. So the first thing, identify the types of tests to be performed and assign it to the development. So now, this is, I told you that STLC is we as testers, you and I, because we've chosen this path of career. So it's between you and I. This is our job. This is our role. This is what we're meant to do when we are every don't now I want you to have it at the back of your mind is that anytime you are working on the field, you must use this process. It's a must. It's just like you to say, this is what we entail. That's we. So we must use this process. Gather details about testing priorities and focuses. Prepare the requirement traceability matrix. I told you what RTMs are. You get the requirement. This is login. All the test cases that you have created, we link it to the script. So this is the way we're going to do. I am going to, as I'm doing this, tomorrow I'll start giving you assignment. So by tomorrow will be the first time you have your hands on. Don't worry. Don't be scared. I don't want you to panic. It's something that I don't need to tell you. Once I do, I show you how to do it. And I do it in the class. Believe you me, fantastic ideas is going to come out of you all. I'm so certain. It's not today. When I see people's script, I'm so happy that, oh, these are my students. So I am very sure you are going to do it. But this time around, we also are going to do RTM, every one of you in your individual projects. And I'm going to the mentors, I'm going to let them know they need to validate the RTM, this RTM. It is compulsory. If once it's done, when you're working, I always go to Azure DevOps. I've got access. So I look at your script, I view it. I will not correct you. I will only send you a message. I'll speak to the mentor to say, this is what you're not doing. I look at everything on Azure DevOps. I go through it. So when I see your script, I expect you to follow the steps and you must put them there. So I do my own due diligence to ensure that you all are doing the right thing so that when you go into the field, I want you to make the mistakes now so that it's easier for me to correct you than when we get into the field. Though you're still going to have help when you start working, but let's correct ourselves. Let's so that you understand it. It helps in interview process. So identify test environment details where testing is supposed to be carried out. Conduct automation feasibility analysis if needed. So that takes us again to deliverables of requirement analysis. I'm going to be, so I've talked about the RTM. So that's the major thing. Sorry about this. So that takes us there. Then automation feasibility report. I think there was a question about this in the last class. So now test planning. We talked about the test planning, which I talked about test plan and test strategy. I will teach you how to write that too, and I'm going to give you a review about that. Activities of test planning. These are the things you do. Preparation of test plan and test strategy document. Selecting any tools required during testing. Test effort estimation. Test training requirements. So all these are the activities needed. Deliverables of test planning. We talked about test plan document. So we follow our ISM because, and also note it while you are here, as long as you are here, you would once you finish the training, even before you finish, most people always get their at least their foundation, ICEPS foundation. You will do it and you'll be qualified. And once you do the foundation, that's it before you start preparing for the intermediate. But with the foundation, it gives you an edge. It gives you that, oh yes, I'm prepared to know that I'm doing something. So you will have the chance. You'll be given dumps that will help you to practice more. So all these things that you see that we're lecturing you about is what is still going to come out in the exam. Testing effort. So test effort estimation document. So that's it. So now we talk about test case design, test case development. I'm so certain I gave you an example, but the main thing about test case, I will talk about it, which that's what we're going to do. If I start it today, we might finish it tomorrow. If not tomorrow, that's my major task, and we'll finish it tomorrow. Then test case, then activities in test case. Activities in test case design, preparing the test cases and any automation scripts if needed. So the next thing is enumerating the possible actions of the users and the objectives. Well, setting the priorities of test conditions, selecting the conditions under which testing will take place, documenting any test conditions. I explained test condition, but don't worry, I'm going to still explain it. So verifying and correcting test cases based on modification. These are the activities, these are the deliverables. So deliverables of test case development. Test cases, this is set of action that tests a particular piece of functionality of the software project. What is test data? I told you in our general testing principle, um, I think number five, number six says testing is context dependent. So, which means you use something, the things that you need to use to test it, what you are going to type using like username, things, those are test data. You will see what test data are called when we start creating our script. So test automation script, you are going to be taught how to automate here. So now that is sort of test environment setup. This is like an environment where it's suitable for us to do our test execution before it goes into subsequent environment. So they mimic whatever we got in production, they'll put it for us in test environment, then we can test. So anything we just make sure is the mirror of what is going to be the end product. So that's the test environment. Now, the activity of test environment, in test environment, analyzing the requirements and preparing the list of requests, required hardware and software, setting up the test environment, executing a smoke test on the test environment to validate the readiness and stability of this. Then deliverables of test environment setup. I am not too fast. The reason is because I've explained this in details. So I need to go immediately to what we have. But I'm recapping because we've had a break. So I want you to, so I'm not, I'm just trying to hit where we are going to start immediately. Then I will take my time to explain where we have. But I am certain that I have explained all this part. I know where I'm going to start. So very soon we'll be getting to what we want to do for the day. So the test environment, our deliverables, what we're meant to ensure is that the test environment is ready for test execution phase. Smoke test results, I explained smoke test the last time. So those are the deliverables that we have. What is test execution? I explained how test execution are done. If you've got 5 test cases, you should ensure you are not talking, you analyze in percentage. You analyze in percentage, not in numbers. You do numbers and percentage. When you're asked, you will do both. So but when you're saying 60% passed, 20 is blocked and 20 failed. That's the analysis. So what are the activities? Execution of test script, test cases, recording results in the company's test case management tool, reporting any defect for any failed test cases, retesting any defects after these have been fixed by the development team. So we've got regression, we've got retesting, which I told you that retesting is that you have raised a bug that the username is not working as expected. When it is fixed, the developer will tell you, I have deployed into the test environment, it is fixed. Your duty as a tester is to go and say, okay, I'm going to retest it. You retest. So when you are retesting the exact bug, the step that you created, the step that you have written to reproduce the bug, you try to do it again. So when you try to recreate it and you see that it's working as expected, your retest has passed. After a retest, a regression follows immediately. They are brothers, but you do one before the other. You retest first, then you do regression. Regression is that I have retested, but I want to be sure that anything that has been done previously has not, whatever fix that was incorporated, whatever fix that was used to fix the bug has not broken anything that we have tested previously. So regression testing has to follow. This is the way it's done. Then deliverables of test execution. What are the deliverables? Report on any defect that have been raised during the test execution phase. So any defect that have been raised, you have to report on it. Then overall summary of the test case results. We have to give them. We have finished execution. After you finish execution, give them the analysis. This is what has passed, everything. You have to document it. It has to, you people have, make sure your summary is always intact. Even if it's a 1 pager, if it's 2 pages, just let them know this is what we have achieved. This is what we did not. Is it green? Is it amber? Is it red? Explain it. So that's the deliverable. That takes us to the test closure. So, and test closure is that we have finished everything. We have walked through the all phases. We have done our execution. Now we want to evaluate it. What is it? I've finished all the work. I need to sign it off. What has worked? What didn't work? You put it in a document to say this is your sign off. Are you happy with it? Yes or no? Or at this environment, we can push it to the next environment, then pending the time we wait for the fix. So the QA team meets to evaluate the cycle completion criteria based on the test coverage, quality, time, cost, software, and business objective. The bug and test case results are analyzed to identify the distribution of defects based on severity and type. After completion of the test cycle, the test metrics and test closure reports will be created. So, what are the activities? Preparation of the test closure report. Evaluate the cycle completion criteria based on your test coverage, the quality, the time, the cost, the software, and business objective. That is the way we evaluate the criteria. In terms of test coverage, you have written all the tests. Are all the priority of the test? The first thing you put is the risk, the priority. Have they been tested vigorously? Do you feel you have good test coverage? Has everything been executed as expected? What do we have left? Now, the quality. Are you happy with the quality? What exactly is your concern? You let it know. If there's no concern, or the quality is fine, we've just got medium or low, like the color and things like that, that can still go. The time, the cost, the software, and the business objectives. So all these are the things that we put in place, the activities that we need to perform. Test metrics based on the above parameters. So we need to state the test metrics. What are the test conditions, the test cases executed? Do your analysis based on that so that you know everything. That's what will give you the number of test coverage that you have. And that's why I said your RTM is necessary. What is deliverables of test cycle closure? Test metrics, text closure reports. These are our key deliverables. So a document that gives a summary of all tests conducted during the software development lifecycle. It also gives a detailed analysis of the bug removed and removed. So that takes us to the big part of today's lecture, which we start from the defect life cycle. So from this defect life cycle, what is defect life cycle? So it describes the different states a bug can be in through its entire life. It can also be referred to as the bug life cycle. Defect. If you see that when we started the initial class, when I was talking about error, defect, failure, now is bringing it back. I told you from the beginning of the class, every word you're going to be hearing are just repeated words. They are things that you've heard before. They are terminologies that you know before from the previous class. So now these are things that we now need to bring to for you to see it, how it works in life. Now, defect, it will tell you now we've got a bug. There is a life cycle, there is a process for the bug. So, what is the process for the bug? That is where we want to take as we go along to say this is how the bug life cycle goes, this is what is necessary for bug, this is the state that it is. I'm going to tell you each of the states and you will explain to it. So the different life cycle also involves the classification of the different priorities and severity. Now again, please take these two words, priority, severity. Priority, severity. Look, those twin words I'm giving you, there is certainly no interview that you go to. If you pitch on it, they will ask you question on it. I will ask you question because the reason is that most these twin words, people miss it a lot. They mix it. And when you ask them, they forget. So that's the reason these words, I always, if I'm lecturing, I make sure I tell you. I've given you like almost 8 of them. So I need you to be going into each of these twin and ensure that you have them, you know what they mean. Priority and severity. What is priority? Priority of a bug. Now we are talking about it in defect in a bug. So for example, priority is classified under high, low, medium. So priority is you have found the bug. If you want to look at the bug, how do you want to rate that bug? How do you feel that bug can be rated for people to know what the priority of the bug, the priority of the fix of the bug? That is what priority is about. Let me come again. You have raised a login bug. You said you're unable to log in due to username incorrect. You are unable to log in. If you cannot log in, can you do anything? So when you now raise that defect, you want to set a priority on that defect. When they put it high, medium, low, then you can say it's a high because you cannot do anything, you cannot log in, so you cannot test. That's a high, that's the priority. Now let's take it to severity. Severity is you now thinking that how does this bug, that exact bug that I've raised, how does it affect this application? How does it affect what we are doing? Now, you cannot log in. It means anyone that is going to use this application at that time cannot log in. It is a severe bug. Now, the classes for severity, they are classified as critical, major, medium, low. So it depends. The critical, major, high, medium, low. Critical, major, they are like, we cannot go further. This is a critical one. Or you try to launch a browser, your testing browser, where you want to go. You've displayed your endpoint, but it's not going through. You cannot launch it. It is a critical bug. It's a major one because you cannot do anything on it. It has blocked you. You are impeded. You cannot move further. You are blocked. So it's something that you need to escalate quickly. That unfortunately, this is not working, and you escalate it. So that is severity. Severity is that we want to know how it affects the entire process. But priority is that this is I've raised this bug. This is how we are rating that bug. This is the way the bug is. This is the level of the way we can fix it. Because the reason why we need the priority is that when bugs, we have like 20 or 30 bugs. We've just got 2 developers or 3 developers. It's kind of much for them to. So the first thing is that we first filter on the high priority. When we look at the high priority, oh, we've got 10, we've got 15 high, that's fine. We first let them fix the high ones because they are critical. Then the next phase, we take the medium. We've got 10 medium. Then that's fine. We can still go. After we finish the high, if we have time, we'll go for the medium by selecting the ones that we feel that is meant to be suitable for high. Then the low. The law is that we can do away with it. Same thing about severity. They work hand in hand. So it's an interview question, please and please. So defect priority refers to the order in which defects should be resolved from the QS team perspective. So you and I have explained to you that I have tested the logging. I'm unable to launch the browser. I'm unable to use the test environment. Then when you raise that defect, you state a priority I. It will be the greatest one, the highest one. So that's the I. So priorities are determined by yourself, by you as a tester. Now, you know what happens is that most of the time, I will tell you like that. Sometimes you set it that, oh, it's I. The developer will say, no, no, no. People may say, no, it's not I. That's you are the one that set it. When you set something, always know how to back what you have set. If they tell me that, no, with the login, that's not I will now ask you the question is that I cannot log in. I cannot access the environment. How do I test? That ends the answer. Nobody will answer, oh, that's true. That is I. So it's an immediate thing they need to fix. So you are the QA, with the QA team, the team, because sometimes you might be the only one a project. It depends on how large your testing team is or the resources available at that time. So ownership should be done by us. While defect severity classifies the impact of the defect and the complexity of the fix from development team perspective. So they also involved in the severity. I've raised the one that I said is I. They know it's a severe one, it's a critical one. There's no point. No, you have developed an environment, we cannot launch it. So what have you done? You've not given us anything. So they would say, oh, it's a critical one, let's fix it quickly. That is it. Please and please. You see that I explained before I showed you what I have. This is key. So that takes us to the life cycle of it. So when you see a defect, you'll be asking that, how does it work? How is it? So I'll take you into this loop and this diagram for you to see. So the first thing, every defect that you first raise. Now I found a defect. I put a step to reproduce it. Please note this down. When you raise a defect, things that should be in the defect. Number one, the defect must have a title. How do you give a title? User is unable to log in. So immediately anybody picks it, he or she knows that it's a login issue. The second thing it must have, step to reproduce that bug. Steps. Number one, go to www.bluesky.com. Click on enter username as Yemi1. Enter password as password1. Click submit. Now, the way I raise my bug, I put my expected and I put my actual. I'm not going to stress that with you, but after you have raised it, you have said that step. Then the next thing is you tell them in your step to reproduce it. When you click on this, then you need to let us know what the bug is. When you say, okay, I've clicked on it, click submit. Error message getting displayed, unable to log in. That's the error message that I'm getting. So that's your step to reproduce it. When you get that error message, take a screenshot. Ensure, let me see whether, I'm so sorry, but I'm trying to, I can't share my screen. Sorry, because I've got some things opened. So if not, I would have been able to share it. But in the next class, I'll tell you how to take a screenshot. You must take a screenshot from where your endpoint is down so that people can see the URL and a picture of the error message that is there. Add it into your script, into your bug, then you save it. It must generate a user ID once you create the bug. That's the way it is. Those three things are important. Ensure, no matter how necessary it is, add a picture. Now, the reason for a title is that before people can go into the step, they already can visualize and also analyze that the issue that is having is logging is a critical issue. They open it and read the steps. Fantastic. Yes, but they might say the person can try to reproduce the step and say, oh, it works for me. It's working for me, but it's not working for you. But when because you have added a screenshot, nobody can question you. You can fight on that screenshot to say, it's a picture. You did not design the picture. You took a screenshot of the picture. So details are there. They can go to the host and look at the endpoint you have put there and be able to debug from that time, whatever has happened, and fixes can be done. So that takes us to the first thing. So when you create it and it's the state at that time that you have created turns to new, is new. So I'm going to go through the happy part first. Leave this side first. So after new, we take it to this point which is opened. What? How does this state change to open? It depends. Some tools call it active. After the new, there's a defect triage. What does defect triage means? It means we come together as a development team. When all these defects are raised in the morning, we have a defect triage session. And that triage session will say 25 bugs were raised. User unable to log in. Yami, what happened? Details are there. They would have seen it. Oh, okay. Is this a bug? They will speak. The developers will say, "Oh yes, we know there's possibility that there's an issue. We can fix it." Then we change from this new state is changed to open or active state. So when it's active, it means it's been triaged. Someone is working on it. Then once it's done, we put it in a fixed state. Once the developer finishes, because once it's active, it means the developer is working on it. Someone has picked it up from the development team. They're working on it. Now it's fixed. They change it to the fixed state. At that fixed state, sometimes it's called fixed or resolved. That stage is left to us to retest. Now it comes to us when we see it. We test and we use the tool. We make sure that everything is tested. We retest, look at it, is working as expected. Yes, it's fine. Happy, yummy. Yes. Again, at this stage, when you retest, I'm emphasizing on this because what I find out is that most people that we still forget this process when we're working. Most of us, we forget it. I am very used to because I like people to do things that when we come back to this defect in a year time or in 2 years time, there are history about those defects. When you work on a project and you are finished, you might be moved to another project. Is when you come back and, oh, Yami, there's a defect here. Please, can you help us retest? When you go back to the ticket, the screenshots can bring back the memory of what you have done before. You can't put everything in. So with those screenshots, it gives you an explanation that it is it. So another thing I want you to note is that anytime you do a retest, ensure you add a screenshot and say, simple note, login is what we used. We said, error message coming back. I've retested, is working as expected user, and when I clicked on submit, I'm able to launch the browser. First, the thing retested in seat environment, in test environment. First stop, working as expected, as user is able to log in. Now, take a screenshot of the landing page that you're seeing. Put it there. I start from the beginning of where I have clicked submit. I take first screenshot, I add it. I take my second screenshot when I've landed into the page and I added it. Save it. Working. So then after you have retested, you have put all your test evidence there. Those test evidence are key. You might come back again. This same login might regress. What does that mean? Maybe we have deployed another code in another time. It fails. And they will ask you, Yemi, but you said you retested. Yes, I did. I retested on, go back to the tickets on the 24th. The tickets we capture the date, time. There's history log. It cannot be deleted on that ticket. So it knows who logged in into it, who did this into it. So at that phase, if I've retested and I see that, oh, I've retested it and it was working when I tested it 2 weeks ago, we'll go back to it. I don't need to talk. Just go to defect 833118. Simple. You give it to him. And we go into it. This is my state. This is my test evidence. You too, if someone has test evidence and said he's working at that time, what do you want to do? There's an evidence there. There's a picture format there. But if you just write it that is working as expected without no picture, I can't validate the truth. I'm not saying it is wrong. You got it correctly, but I don't have an evidence. When you go to have cases in the lawyers, police, everyone, they ask for evidence so that when we see the evidence, it is easier to be able to know the truth from the evidence. So that's what we are doing. After you've retested and you see it's fine, then you can close the ticket. That's the happy scenario. A new defect has been created. Now, let's now go back to the loop again. When you create a new one, we've created a new defect. We are now at the triage session. It's two-way. Is either is going to be active, or if they find out that no, Yemi, it's not a bug. We it's not a bug. Oh, quickly, let me share my screen. You can see this is not a bug. This is what you're meant to do. This is what you're meant to do. Okay, accepted. You to quickly check it, then we can reject that bug. Then that bug can be rejected. Now, another phase is we have done it, is now active. The developer is working on it. Maybe he feels it's kind of, there are certain criteria need to be met before this fix can be completed. We are still here when we discussed it in the triage. If he says, oh, yes, I agree it's a bug, but before this bug can be fixed, we need to do this fix, we need to create this, we need to add this into it. Then we can defer the bug to say, leave it opened as active, but it will be deferred until the other criteria have been met. So in the ticket, the defect manager or whosoever is running the defect triage, it could be you and I. We could help. It could be the test manager. So anyone could run that defect. So if that person has to write it, comment for the day to say, this criteria needs to be met before this bug can be retested. Hence, we defer it. So we leave it there. Now let's go back to the loop. New, open. Once it's new, we've turned it to active, someone is working on it. Then once it's fixed, we are happy that yes, it's fixed. The developer has fixed it. He said, Yemi, retest it. So the tester now picks it, I'm retesting it. When I retested, I'm not happy with it, it still failed. Then I reopen it. Once it's reopened, the developer picks it up again, he fixes it, And once it fixes it, it sends it back to retest. If you're not happy, you go through that loop until you're happy. Once you're happy, then you close it. This is the whole defect life cycle. Just ensure that you understand each phase. This is what a defect life cycle looks like. So that takes us to defect life flow states. So I will start explaining each of them. The defect has been raised, but has not been validated yet. That is it. We have raised it. We don't know if it's a defect or not. You found it. The next thing is we assign it. That is the open state, active state, that is the assigned state. A member of the development team has been assigned to that defect. That's the open state. Then that's the active state now is that the defect is now being investigated by the development team. So now the developer has picked up the defect. Let me look at it as the developer. Is it a defect? Oh, yes, I'm working on it. Now, what's the test? The test part is where the defect has been fixed and is now ready for QA to verify. That is the test. Once it's done, we are the ones to test it. Now, you are not happy with it. If you look at the loop, I told you, oh, I'm not happy. The proposed fix has been rejected by a QA team. So the issue remains unresolved. So it's meant we take it back to the developer. Now, verified. The defect has been fixed and verified by the QA. Happy? Yes. We close the defect. If the defect no longer exists, the state of the bug is fixed and set to close. This is the state of defect life cycle. The parameters here, that's the names, these values here. The names can be changed. Some call it assigned, active, open, test, reopen. The ones I know still remains consistent: reopen, closed, new, assigned, active. So this test might be resolved. So all this could be, they are the defect life cycle state. Then there's a rejected part. I'm not happy with that. This is not a defect. Oh, it's not a defect. It's been raised already. It's not defect. It's not productive. Then reject the defect. The other one is the default side. This is when the bug has been prioritized for the next release. We cannot do it. Maybe by the next release, we fixed all the criteria needed, and then it's done. So that's defect priority. So what is defect priority? The QA team typically sets the priority status when the defect is brought to an attention of the development team and is based on the end user's requirements. Low priority. So now I'm explaining to you defect priority. Low priority. The defect fix is not of an urgent nature and can be delayed until more important fixes are completed. That's low. Let's take an example. Maybe the logo on Blue Sky is meant to be dark blue. That's what the requirement says, but it's currently light blue. We can change the logo anytime. We can work on that. We can add a dot to Blue Sky at the end of it. Those are low bugs. There's not much impact. We are the ones that looking at the design. The major thing is the functionality. Is it working? Can we pay? Can we view things? Those are the key things. That takes us to medium priority. The development team should fix the bug in subsequent builds. So medium, yes, we can still fix it. Let's take it in this next build. We can fix 3, 4, 5 medium bugs as time permits, as we can finish up quickly. So these are things that needs to. Then high priority. The impact of the bug on the software is substantial and should be addressed immediately. You see this word immediate, it's this one, like in your text closure report, even in your daily report, before you can sign off, listen carefully, before you can sign off anything, all high priority must be fixed. Must be fixed. If not fixed, mitigation plan should be laid down. But it's a must for this priority, high priority to be fixed. Take it that way. Because if it's not fixed, I can't access I can't access and I can't access a website. There's no point going further. If you as it, there's no point because it means it's a constraint on others. They can't use it. So it has to be fixed. It's a must. But we cannot say maybe mitigation plan. Maybe it's glitching. Sometimes immediately when you log in, the first time you log in, you might not be, it will crash. The next time you immediately when you hit enter, it logs in. Plans can be, but I'll tell you, it's better. High priority needs to be fixed. Urgent priority. The product cannot be used until the defect is fixed, so it should be resolved urgently. It's a must. So that takes us to defect severity. Defect severity is based on how severe the defect impacts the functionality of the software and how complex it is for the development team to resolve it. How complex is it? One, critical severity. It's a must. The critical is a must. The defect affects the core functionality of the software, and the QA team cannot continue testing the product until it is fixed. That is where we are now. We have raised a bug that we cannot go further. So it has to be fixed. I said an example of a defect that is critical severity is one that causes the product to crash often. So you can't. I've tried to launch the browser, it's crashing. So it means if we do away with it, if 10 people, when it gets to public and they all log in at the same time, it crashes. It's waste of money, waste of time, waste of business reputation. Those are the consequences of not testing adequately. So those are the consequences. The next thing is major severity. The defect affects core functionalities considerably, but the test team can continue testing other aspects of the software without this one first having to be fixed. So I can continue, but it has to be fixed. It has to be fixed. Then the next thing is the medium. The defect impacts just one screen or one specific functionality, but does not actually stop the function from working. So a medium bug can be maybe you've logged in, you try in your requirement, it says in the menu bar, it must have items, add items, create items, delete items, change item. So maybe like change item is not there. You can still be testing other functionality. You raise a defect for that and let them know that this is not there. Please, can you add it? But it's not stopping you from testing. Then we've got the low severity. This defect has no impact on the product's functionality and is likely to be purely cosmetics. And that's why I used maybe the logo, the color, they're just cosmetic bugs. Fixes they are likely to improve UX and UI. So that's it. So now that takes us to this is states the end of STLC and SDLC. But I want us to understand the difference. So what are the difference? SDLC, software development lifecycle, is testing lifecycle, we know. For SDLC, the major objective of the SDLC lifecycle is to complete successful development of the software, including testing and other phases. While STLC, the only objective of it is testing. You know, I've iterated quite a lot about it. So the development life cycle is every one of us as a team, including developers, business analysts, Scrum Master, BA, yourself, you and I. But for the STLC, the major objective of the STLC phase is testing. In SDLC, the business analyst gather the requirement and creates development plan. In STLC, the QA team analyze the requirement documents like functional and non-functional documents and create system test plan. So it is our own job when it's STLC. Though it's requirement gathering and analysis, but it's done by us, requirement analysis. In SDLC, the development team creates high and low level design plan. In STLC, what we create, the test analyst creates the integration test plan. We create the test plan. The real code is deployed. And actual work takes place as per the design document. The testing team prepares for STLC, the testing team prepares the test environment and executes them. That's then SDLC phase also includes post-deployment support and update. Testers execute regression suite, usually automation scripts to check maintenance code deployed. These are just few differences between SDLC and STLC. That takes us to this phase. Before I move to the next bit. So this phase is correct. So this phase is requirement analysis. That's what we do. But for we as tester, we do system testing. High level design, we do integration test plan. Low level design, we do unit testing. Then coding is the big guy. So this is SDLC done by the whole development team. This is what we as testers do. So that ends the big picture of SDLC and STLC. So before I go further, I'll quickly go to, let me go to this space and just ask this time around. Okay, I'll wait till the end of the class because I wanted to ask some questions and I would have loved to. I'll ask everything together at the end. So that takes us to the next bit of what we want to start, test levels. So it takes us predominantly to where, what are the test levels that we have? If you see, I built them in blocks just for us to know what what it entails. We starting first, then the next thing. So this person from here starts unit, that's component testing. So this unit testing, we do some in terms of developers. That's where the code bit is. So once the code is being developed, then the codes are developed in components, in modules, in bits, little by little, small. That's login is the code. That's one component. Submit, it's another component. Search is another component. Launching it is another component. They are all bits and pieces, but they come together. They are unit testing, so they test them in isolation, standalone, coded. Then after they are happy that login works, then they do an integration. So I've coded login, just username, start from the URL, we know the endpoint, that bit of code has been kept. We go to use the username, password analysis. Those code is being another component. The developer has tested the first bit of it to see that, of course, we can host that browser. That browser exists. Now, that page is shown where you have the login details, the username, and the password. That's another bit of code, but it's separate. It's separate. He tested it alone when he did the URL. He created another code and tested it that that login will work. Ensure that code is working. Now, the submit is also a little bit. It created that code to work. Then the next thing is that it did another code to see that the landing page is there. That's another code. Let's take those four. How is, after that component testing is done, now we've got the integration testing. What is integration testing? This is now the first thing that those things that the developer has created, the code in bits, the component testing that have been done, they need to link them together to form one. So that it's not that the URL, the endpoint is standalone, the login is alone, is not linking to anywhere, is not, so we need to bring everything together. So it starts, number one, get the URL, that's, I can launch the page. Then it links it that immediately you launch the page, it links it to the login, enter username, password, and do everything. Then after that one is entered, it links it to the submit. Once it integrates it to the submit, then the last bit we integrate it into is the landing page. Now I can see everything in the landing page. That's the integration level. Then the system testing level. That has been created, it's been integrated. Now we are looking at the whole thing. Is it as expected? Is this the system that we're expecting? Is it from the endpoint to the user? Then it's there. Then what It's just system is the validation phase to see that yes, is as expected, is integrated correctly. As from endpoint is number one, login details number two, submit three. Then the validation phase is four. Acceptance testing. Is this exactly what is in the requirement? Is this what the users want? That's where we do the acceptance testing. So these are the levels of testing that we have. That takes us to types of testing. I've been talking all through. So now it leads us to types of testing. What are the types of testing? We've got various types of testing. Non-functional testing. What are non-functional testing? They are testing that you cannot, they are, they are things like performance testing, talking about you want to know the capacity that a website can take, the load, the volume that it can take at once. For example, when we are testing, we might be able to test maybe one at a time is working as expected. When 10 people sit together and test at the same time, will it work as expected? You know the way it's going to take for one will go speedily. When you add 10 people now, it's not going to be as quick as one. Now take it when you take 100 people, it's not going to be as quick as the one you did for 10. Take it now when 200, 1,000 people work. So non-functional testing needs to cater for the load, the stress, the volume that is going to use. Let's take example of social media. A lot of us use that at once. I'm talking now, billions of people are using it currently. Millions of people are using each of these immediately. So we want to be able to test that when they are using it, it doesn't crash. Those are the types of testing we want to do. So those are called non-functional testing, which performance testing, that's load, stress, and volume testing. We've got security testing. What is security testing? You are using your card to make payment online. What you want to validate here is to ensure that when you make payments, people cannot hack the system and do like an F12 and see all your cards. No. Usability, the usage of the system, compliance testing. What are the compliance? So what there are certain rules, certain criteria to be met. Are they compliant? Are they following the regulatory? Those type of testing are key. Sanity testing. Sanity, you have done a smoke test. Easy smoke test, I can do it. Now, sanity test is more of a regression test to say, let me check. You have done, they've built a build, they've deployed, a build has been deployed. You have done smoke test. You just want to do a sanity test to ensure that the the build that was deployed did not break any other thing that is within it. Is every other thing is still as expected before a proper regression is done. That's it. Structural testing. All these are types of testing. It continues to say functional testing. That's the behavioral testing. Let's take the functional testing. What are the functional testing? You're talking about logging. That's a function, a feature. Future is also functional testing. So if you're talking about search functionality, talking about menu, all these are features on the application. We talk about smoke test. What is smoke test? When a build is being deployed, then we need to test. We need to do some certain level of testing. That's what smoke testing entails. Then the next thing then the next thing we have is retesting. What is retesting? I've explained to you. We have found the bug. We are retesting that bug. We are retesting that bug. So the bug you have found, you said the username the page is not working. Now they have fixed the bug. The developer has fixed the bug and he has deployed it to test environment. The first thing is to retest the bug. Follow the steps that you did initially to retest the bug. As the bug been fixed, yes, it's been fixed. Then you do a regression testing. What is regression testing? Testing after code has been changed. Because they have done a fix here, they have changed a code, they have fixed something. So we want to ensure that everything they have fixed is not been affected. The other ones that were there before have not been affected. That's the reason you do a regression. So these are types of testing. So testing, what does testing do? What does it do? Testing verifies and validates that the software or application is bug free. That's the reason why we are testing. Testing identifies defects or bugs. Testing helps to identify failures of software. That's what it is. Then we've got debugging. What is debugging? Debugging. I am debugging. You have found a bug. You want to debug it. You want to find the cause. You want to find a fix. That is it. Debugging is a process of fixing a bug or defect in the software. Debugging removes error. Debugging identifies, analyzes, and removes bugs. So when you find a defect, like I always, maybe, it's a level, it's a phase. Because I love to, when you're doing automation, you will have to debug. Manual testing also with debug. For instance, you have added your user ID, you put everything. You can see it was working as expected before. Then 5 minutes later, you went there to try it. You tried it severally, it's not working. You want to know what is wrong. You can look, oh, what are the things I'm not doing correctly? Are my spellings correct? What I've done. So you try to debug, try to know what you have done so that it's easier. It's not that you didn't, maybe for example, you're meant to add a character. You didn't add a character and it wasn't working. You didn't even know the reason why it's not working and you can't figure it. But if you debug, it could bring you a memory, oh, am I meeting this certain criteria? So it debug for me, it's that way. Or you've written your automation script and you're trying to execute it, it's not working as expected. You need to debug. Why is it failing? Those are debugging. So that takes us to another phase, which is static testing. Ah, so it says static testing. So static testing done when code is not executed. Static, I'm just standing. I'm not doing anything. I'm not validating anything with code. What can be static? What can we do static testing on? Take an example, a requirement. You're reading through the requirement. You are checking the grammars. You are checking as if, no, do you understand what that book is all about? Take a novel. Take a storybook. You can do a static testing on it. Start reading through it. Look at the content there. Are the spellings right? Is this story, do I understand what it means? Those are questions that you ask. Static testing is done at verification stage. Don't forget, when we were talking about the V model, when we're talking about validation and verification, now we are bringing it to life in type of testing. Why I love testing is that all these terminologies I'm using, I've started using it right from the beginning. It's going to be the same thing you are going to use on the field. I call them testing jargons. They are things that I want you to be speaking when you're talking to me. Those are the languages I want to hear, because these are things that you are going to be using on the field when you're talking a verification stage. Look, it's coming into play again now. This is done at verification stage. It means before we are checking, we are verifying that is the product right. That is what we are doing. We are validating the requirements to know, do I understand it? Code is being examined without being executed. You can look at the code. You can, maybe the developer calls you, come and just check the code. You can just read through the code. We are not executing it. We are not touching code. We are not executing anything. That is what is done in static testing. What is dynamic testing? Dynamic, in the English sense of it, is moving. All these things has to do with and the way English, the meaning are the same thing. Dynamic testing is moving. This is done at validation stage. Now, is the product right? Is this the intention of the user? But at this stage, code is executed. The developer needs to bring something out for us. We need to test it. We need to validate that it's working as expected. These are the types of static background to static testing technique. So that takes us to review and types and the test process. What is review? So we've got different phase of review, which I would talk about it in today's class. A review is a systematic examination of a document by one or more people within the aim, with the main aim of finding and removing errors. Take an example. We want to review the requirement. The earlier we find this error, the better and the easier for us. That's why early testing is key. When you're given a requirement, a user story, you read through it, you try to visualize it, think about it. They're talking about login. What are the things? You have put a big word here, a big user story. It's not broken down. What are your expectations? What are the acceptance criteria? What are needed? Those questions, you need to force it out if it's not been given. That's what brings up the memory for us to understand that this is what we're doing. Then given a draft document to a colleague to read, a simple example of a review. I've written the user story, the business analyst has written it. It can say, oh, tester, please, can you help me review it? Do you understand what it means? So what he or she means is that review it. Do you understand what that thing is saying? If you don't understand it, no other person can understand it. So that's what we are trying to do. So if that's an example, a document can be given to you to, and one which you usually yield a large crop of errors than would have anticipated. So you have given a user story. You can now ask, oh, you said the criteria is meant to be this. Are these the only criteria that are needed? You didn't add special character here. Do you just don't want it without the special character? Are you happy with what is here? These are your things. So those questions are things that it allows you to ask at every phase. So this is the review stage. So now, what are the types of review? We've got the informal review. Informal review. We've got the walkthrough. What are the walkthrough? Walkthrough is like telling me, explain to me how this application works. Give me a demo. Give me a demonstration of how it works. In the layman language, let me say, walkthrough means teach me, train me how to use this application. Simple. So when you get to an organization, I don't expect you to know the application I'm working with. I use policy admin systems. You might have not worked in an insurance organization. I don't expect you to come and do any miracle there. I need you to walk you through. I need to walk you through the system. So it means I need to train you. I need to explain to you. I need to demo. Demo is to demonstrate how the application works. Informal review, reading through a simple document, having a review of it, doing like a static testing, engagement with staff. Those are the informal review. What is the technical review? There are technical documents. So we can go through the architectural diagrams, review it, look at what it is, what are the interfaces, do I have an understanding of it? That's review document. These are done by specific people. Then we've got the inspection phase. At the inspection, we invite there are specialities, people that can be drafted in to do the inspection. So we look at it. They have their specialty in expertise in different areas. They can inspect whatever document, whatever application, whatever projects you're working on. So these are the types of review. Don't worry, I'm going to give you time to ask me question. So that takes us to the next chapter. And this, I've given much information tonight. I'm going to start here again tonight, but tomorrow I'll still start from here. So this is where our job is. So tomorrow it's going to be like a class an interactive class where we are going to talk about this script, and I would be demonstrating how to use this script, open my Excel, give it to you. We'll start doing it together in the class. So here, let's define a test script. In the previous class, sorry, I need to charge my 1 minute, please. I need to fix the charger. So sorry about it. So I'm just trying to charge my laptop now. So that takes me to this to say, talking about test script. So I'm going to define the test script and I'll take it to test condition. A test script is a set of instructions that is performed on a system under test to verify that the system performs as expected. So it's working now. Sorry about that, guys. So test script is a set of instructions that is performed on a system under test to verify that the system performs as expected. They can be written in either human language, used for manual testing, or a scripting or programming language used for automation testing. So it's either way. The one we are going to do is the manual bit of it. And we are going to be using human language, English language. That's what we are going to use to write it. Simple, concise, precise tests. A test script is a part of test case, and a test case can have either a single test script or a multiple test script. Multiple test scripts are associated with a single test script when one, each test script provides a different way to test the scenario. I'll explain to you. For example, if you have written a script and there are certain criteria to be met, then we can link those criteria to another test script. Let's take an example of a login. Before you can log in, there are some assets that you need. You can write a test script to say, before you can use Blue Sky to log in into that test environment, you can design a script to say, test script, in the test script, access, use this access. You must be able to access an application. I'm trying to use a website. In a context, in an organization, in a real world, before you can use some application, you need to get a proper access. So what the access will give you is, they need to add it maybe to a database. Once your name is there, that's when you can get access to use it. So the first thing is for me to write a script to say, that script, I need an access to it. I keep that script there. Now, until I get that access, that's when I can start proper testing of that website. That's when I can start writing login details, login with valid details, login with invalid details. If I am going to do that, inside that other script that I'm saying login with invalidity, I'll say my prerequisite is that you must have an access. Refer to my script that is in this version. That's the reason you link different scenarios together. For instance, a test case might require several scripts to test the scenario in different test environments. So if I need to test it in SIT, it's going to be different when I'm going to UAT. UAT is acceptance testing and user acceptance testing environment. You go to pre-prod. Pre-prod is pre-production environment, and before it's moved to production, which is the live environment. So we start from test environment to UAT to pre-prod, pre-production, then to production itself. Some organization might have more environment. Both manual and automation scripts exist to exercise the test cases. So that takes us to another phase. Let me see the time. Okay. This takes us to, I'm only going to talk about this in 2 minutes, but tomorrow I'll start the class from test script. I won't do whenever, so I'm going to start the class from test script tomorrow, being that it's going to be more of a workshop. So I'll stop the class here, which tonight I would start with saying understanding test case design. So let's take test condition. What is a test condition? An item or event of a component or system that could be verified by one or more test cases, e.g., a function, a transaction, a feature, quality attribute, or structural element. What does it mean? Forget that I've read this. Forget this. Let me take you to the proper, let's take it to real world. What is test condition? Test condition is, I would take an example of an hospital. A patient goes to the hospital. I've done this before. So what it means is, when you get to the hospital, you get to the reception, you tell them you want to see the doctor. That's your aim when you go to the hospital. The question they are asking you, why do you want to see the doctor? And you tell them, I've got stomach pain. the condition you have gone to see. When the receptionist, why do you want to see the doctor? What the receptionist is asking is what is your test condition? What is the condition you are coming to see? So your condition is stomach pain. That's the test condition. Hold it like that. Let me bring it back to our world of testing. When you are asked, what is test condition? Taking login as an example, your test condition, you want to log in. That's one of your test condition, login. That's your test condition, login. Now, remember I said an item or event of a component or system that could be verified by one or more test cases. Now, I've told you what a condition is. The patient says stomach pain. That's it. Now, let's hold the condition. So we are waiting for the condition. He has spoken to the receptionist. Now, let's come to test case. Let's come back to software world, to our own world. Now, it means that a set of input values, execution preconditions, expected results, and execution post conditions, preconditions, post conditions developed for a particular objective or test condition, such as to exercise a particular program part to verify compliance with a specific requirement. What does this mean again? Go back. Let's go back to the doctor, to the receptionist. So it's recorded that that patient, he would have asked the patient about the name and the details. So it's recorded stomach pain towards it. So once he records stomach pain towards it, what is the test condition? I mean, what is the test script? So once he records the stomach pain, before the doctor calls the patient, the receptionist will tell the patient, go and sit down and wait for the doctor to call you. Before the doctor calls, the doctor will need to prepare his test case. Preconditions, post conditions, expected results, and his expectation. The post conditions, the doctor will need to prepare it. So today, we stop the class here. I want to give you opportunity to ask questions. Tomorrow, I will explain to you how the doctor will continue and we'll start our work from there. Thank you all. And that takes me to my own bit of the question. First, we talked about SDLC. I did a recap on that. No more question because I've asked. For SDLC, the question I want to ask is, what are the six phases that we have for SDLC? If you know, just mention, please. Unmute, you can talk now. Anyone starting? We had 6 phases. Remember those 6 phases.
Requirement analysis.
Thank you, Abidemi. Thank you. Thank you so much. Yes. Next person. Next. He has brought it back to life for us. There are 6 of them.
Test planning.
Correct.
Test planning.
Correct, Rafiu.
Text design.
Test case development.
The text design.
Test design. Remember, Read one.
Test case development.
System design.
Mhm.
Test execution,
Okay,
Test environment setup.
fantastic. Tolu,
and test closure.
absolutely fantastic. So these are the phases that we have. So we also move further to talk about defect life cycle. But before I ask my question, I talked about two people again. I said they are twin. Can you remember those two before we continue defect?
Priority and severity.
Priority and
Severity.
priority.
Fantastic. What is priority?
Priority is like the most important defect that occurs. And so we can name it like if it is high, if it is low, or if it is medium or low.
Correct. But I want you to put it, you got it exactly, but I want you to put it in a testing context that just make it a sentence. Try.
Priority.
Priority refers to the order in which defect should be resolved from QA team perspectives.
Fantastic, Debbie. Real one, fantastic, Debbie, fantastic. So what is severity?
It's classified as the impact of the defect and the complexity of the fix from the development team perspective.
Fantastic. Fantastic. So now, what are the stages what are the types? How can you classify them for severity?
Critical, major,
Major.
moderate, minor.
You want fantastic? Yeah. Yes, fantastic, Debbie. Those are the levels. So now, please ensure you know that priority and severity, validation, verification, expected actual, all these things are exit entry. They are always real one, please. Real one, please.
Yes, I'm sorry.
Yourself.
Yes, I'm sorry.
So then the next thing is make sure you understand them. Then let's talk about different life cycle. Can you name some stages of the defect life cycle?
New.
Fantastic. Thank you, Debbie.
Assigned.
Two. Debbie is enough. Now, next person. I'll call names now.
You owe me 10 sweets.
Huh?
You owe me 10 sweets now.
No, in fact, this time around, I need to give you a bag because you've really tried a lot today. Now I'm giving lollies from now on. Debbie,
yes.
I'll give you five
Okay.
now. Five. Fantastic. We are starting with Debbie. So now, anyone that wants lolly, please mention before I call your name. So she has, open. Fantastic. Take one lolly, Evie. Ivy, thank you. Take it. One lolly. Next person.
Fixed.
Fixed. Who said that? Is that Evie again?
No, Ganiat.
Ganiat. Fantastic. Good. Fantastic. One lolly. Fantastic. Now who else? Retest. Fantastic. Evie, another.
No, we open.
Reopened, Ganiat, yes. So now I'm going to call names. If you don't answer me, I'm going to call names. No, Ganiat, Debbie, Ivy, Real One, I don't want you to talk again. So others, I'm waiting. Bidemi, I don't want you to talk. So I want to see new faces. I want to hear new voice. So they've mentioned others. Mention the ones you can say.
Closed.
Huh? Closed. Comfort, thank you. One lolly for you. So who else? Who else? There are still some.
Deferred.
Fantastic. Adesheye. Thank you so much. So I believe you all. There's still one more left.
Rejected.
Verified.
Absolutely rejected. So these are all the statuses that we have. So that takes us to, let's just name some differences of SDLC and STLC. What's the difference?
SDLC, the
S-
main object of the SDLC lifecycle is complete successful development of the software, including testing and other phases. Why STLC, the only objective of the STLC phase is testing.
Fantastic. Oh, wow, my emojis. Yeah, fantastic. Well done. Well done for you, Debbie. Well done, well done, well done. That's it. I'm giving you that clap. Well done. Another
Thank
person,
you.
a dryer. That's a good one, Debbie. Well done. So I'm giving you another 5 lolly. Well done. The next person should take 5 lolly.
In
Who is
SDLC,
going now? Correct.
is the BA that does gathering of requirements and also create development plan. But in STLC, it's the QA team. It's our own responsibility. We're the ones that do the requirements, gathering, analyze it, and do both things like functional, non-functional documents, do our test plan, our test.
Fantastic. That's what I want to hear.
Yeah.
So Bidemi, you get another 5 lolly. Well done.
Thank you.
Well done.
The last one they delivered, I've not finished licking it, so it's perfect.
Go ahead, Nick.
No, don't worry. Comfort. Yes. Next one, please. Are you going? Who is going? One more. Let's just.
In SDLC, the development team creates the high and low level design plans.
Fantastic.
And in SDLC, the test analyst creates the integration test plan.
Well done, Ganiat. Well done. Another 5 lolly for you. Don't worry. Just be checking your post. 5 lollies. I'm sending that. So, any other one before we move to
SDLC also include bulk development support and updates, while STLC testers execute regression suits, usually automation scripts, to check maintenance code developed.
Fantastic, Debbie. Fantastic. Just take another 5. In fact, I'm giving you the whole bag. Share it. This time.
Thank you.
Good.
So that's it. So for tonight's class, that's the end of the question. I don't want to ask you anything about test script. So tomorrow, before I open the floor for your question, tomorrow we are going to come Excel. I just need something like this to come up, something like this. That's what I need from you. So just that's my work. So this is what I want. Just put something like this that takes it out. This something like this. Just come with the empty sheet. Don't worry, I'm working on all these ones myself. So just I don't do anything on it. I just need a plain page, just like this. Like this. Once you come, I'll tell you how. I'll do mine right in front of you, which I'll design. I'll move them and I'll let you see how the scripts are going to. This is what I need from you tomorrow. So once you do it, everyone is going to focus. It's a spreadsheet. Just it. It's a spreadsheet. That's the only thing I need. This is what you need for manual testing. But this spreadsheet, anything you have written here, I will only teach you how to import it to Azure DevOps. So when you are now doing, the reason why I want you to do it on a spreadsheet is sometimes, you might be in an organization where in UAT, let me take my side and subsequently where I've worked. Most of the time, test environment, we might be able to use the tool to put all our script there. But when it comes to UAT users might not have access to the tools. So they will need this spreadsheet to execute. So this is the reason. And if you don't write it properly in this spreadsheet, it will come back to us. It will always come back to us, honestly. So that's the reason I always love you to do it both sides. When you do it there, the only simple thing you're going to do is to do it in another place. And I'm going to teach you 3 ways to write script. The one that will be useful for you to write automation, I will teach you. The one that will be useful, that anybody can pick it when you're doing your normal testing, manual testing, the same thing, and the other one. So these are the 3 things we're going to deep dive into it tomorrow. When I now teach you this tomorrow, then I'll teach you about the technique. That's the way it's going to work tomorrow. So that's it for tomorrow. So the class is opened for question. Any question, please?
Hello.
Yes, please.
So if I may ask, I don't know how to ask my question.
Please ask it anyway.
The bug is being created by BA.
No.
Okay.
The bug is created by you. Okay, Debbie, let's give an example.
Yeah.
I'm not going to do today. I'll give you an example of blue sky. So blue sky. Let me just say, I'll take any one of them. Try to go to blue sky. So let's just say blue sky this is education. This is the blue sky I'm looking for. I click on the blue sky. So when I try to open this blue sky, it tells me to sign in. So I'm just trying to do this thing. So I'm not going to use the right thing. So it tells me sign in. So this is what it brings out for me. You can see, basically close this. Let's say everything yours truly works. Let's say everything works, yours truly. I'm just giving an example. Let's say everything is the right thing that meant to raise here. You are the one that said this. So what I'm expecting from you is that it's not working. You cannot sign in. So what you want to do is you are the tester, the one testing. You have to raise a bug. And that's why I said you give me a title. You give me a title. So what is the title here? The title is that you are unable to log in, log in. Just say unable to log in. Then I say, give me a step. So the step is that first you say, go to this cell that is here, copy the URL just from here. It's you, it's what I have done. It's me that found the bug. Go to the URL. So when I go to the URL, enter. So I say enter, I'm copying the same thing. Enter email and password. That's the enter email as, I don't know, as resumetest@test.com. So then the next thing I say, enter password. Enter password. Password as test. then click. Don't worry, it's because me, I already know what I am. So I click. No, because I said sign in. So I'm just the step that you have said. We have just followed this set. So signing. I'm the one. Is Debbie that has found this bug now? This is Debbie. Is Debbie that has given me title? Is Debbie that is writing the step? Then I now click sign in. So what the actual that I am seeing here, my actual here now is your actual here is error message is displayed. So that's it. So I read it. But the only thing I need to now do next is take a screenshot. Simple way to take a screenshot. There are other ways. I will tell you a shortcut. Alt Windows key, Shift S will take a screenshot of all these places. So if I want to take it, or you take your snipping tool, snipping, just type snipping, it will come up. This is snipping tool. I'll open it. And here. So this is your snipping tool here. Click on new. New. It brings the new. So you can see this thing that is running like the cross. I want you to take it from this point, show everything, unable to log in. So pick it here. So the person can see everything. Copy it, click on copy, go back to this Word document. If this is the tool that you have raised the bug, and put Ctrl V, it will be there. Then you save it to generate it. That is you. So you, Debbie, you are the one that raised the bug. You will be the one to raise the bug. Bug is raised by testers. Having said that, anybody could have found the bug. It could be from the development team, but most of the time they shift it to you to say, raise this bug. Developers too can raise it, BAs too can raise it, but the major person to raise a bug is you and I. Have I answered your question, Debbie?
Yes. Who actually created the bug?
Debbie created the bug.
Oh, how?
Debbie
Found it?
Eh?
I thought I only found the bug. How
You
did I?
You found it, so you need to explain to me. So, Debbie, you have found this bug. This is the bug you have found. Are you not the one that found this bug? So the bug you have found, these steps that you have found, is what you are sending to the developer to go and fix.
Okay.
No, I understand, Debbie. Okay, I get what you mean now. Let me explain it to you. Okay, so Debbie, you have been given Blue Sky environment to test. And this is your endpoint. This is the endpoint. I just picked this endpoint. This is the place that is showing you. But when you try to log in, Debbie cannot log in. So Debbie, you cannot log in. How would the developer know that you cannot log in?
Unless I told them.
Yes, unless you tell the developer that you cannot log in. How do you want to communicate to the developer? You can't do it only verbally. You have to communicate to the developer with what you are saying. Else, this is the way I can convey it to the developer. Do you understand me, Debbie?
Yeah.
So you found it because when the developer deployed this code to this place, Debbie found that I cannot sign in. Hence, because I cannot sign in, I am getting this error message. But when you got this error message, you cannot, if you tell the developer verbally, let me tell you what it is. Let me tell you the trick why we don't tell the developers verbally.
Yeah.
If you tell the developer verbally,
Yeah, because that's my next question. Why can't we just message and say, oh, I'm getting this error?
aha, correct, Debbie. Good question. If you tell him verbally,
Yeah.
what the first question I will ask you, why is Debbie employed? Debbie is employed as a tester to find bug. How many bugs has Debbie found? I only told the developer, where is your evidence? Verbally. The developer can say there's no bug. Yes, but I can tell you predominantly that once you tell a developer, immediately he runs to his code to fix it. So before you say anything, take your snapshots, raise the bug, and now tell the developer. Do you understand me now?
Yeah.
So do is first come first. If you tell developer now, it's a code base. It takes 5-10 minutes. If it's not a complicated one, they'll fix it. They'll now tell you, what do you mean that it's not working? It's working, go and test it again. You will now be like, I tested this thing, it's not working. So it's better to keep mute. Take every necessary information. Ensure all necessary screens are captured. Know that, yes, you can see the message, error message is displayed. Immediately. Look, some days when I do it, I snap it with my, you can take your phone. If you cannot quickly do it, take your phone to do it. If you don't have it to, take it, send it to your mail and quickly, because
Paste it.
once you don't, yes, if you don't, you'll be told that, of course, you did not raise the bug correctly. That is not a bug. So hence, what you have raised, people will, and you too, you are judged by this. Because they'll be looking, oh, she has already found this bug. If that bug comes back, reason why we document it is that if that bug comes back again, if you say, I raised this bug to the developer, there's no evidence. So it's not only by word of mouth, but by raising it by this. So that's
Okay. So it's in the documents. It's easy to bring out anytime.
Anytime. And this one, you are not going to be, some might be doing it in Excel, but you here, you are going to be doing it in the tool. So it's easier for you. It's the same way you do it in the tool that you have done it in this Excel. You see, I'll show you how to use it. I'll get it and you'll be able to use it. Yeah. So
Thank
any
you so
other
much.
question?
That
No.
was good.
Great. Thank you. I'm glad you understand. So any other question, please?
Yes, please.
Eve, please, can you go on?
The sleeping tool, do we need to download it?
No.
Or-
You see me? Just go here. Go to this place. Sleeping tool. To come. Go to your task bar here. The menu bar here. You'll find sleeping tool there. If it's not there, then you can. But often said and none. Look, I don't know, I can't show my keyboard. I would have loved to show a keyboard now. I'd have told you how to do it. Where there is Alt on your keyboard, ALT, beside it is a window screen. Is a window screen. If you hold the window screen, if you hold it down, there's the shift key, that up arrow that is up, that the right shift on it, click on shift and click on S. You have to hold the three together. When you click on it, it will bring up this screen. Look at this screen that you can see. It will bring it up so you can draw it. It's like sleeping tool too. You can draw it and it will give you, once I draw it like this, it will bring it up on a screen. So once it brings it up on a screen, it will come here. I don't know why mine is not. It will come into that view.
Yeah.
Did you get it that way?
Yeah.
Yeah.
Let me tell you the trick of when to use this Alt and this. You see, when you clicked on this thing and you saw this message, it stayed on the pop-up. Before you click on it, make sure, as you see, before I click on it, before I click on this, I'm already holding down my Windows button and this. So when I click on it, I put S. Immediately, you drag it. Once it comes up, drag it. I'll take the screenshot. It will come. It will definitely come. It's for things like that you need to use it so that you can get every detail that you need. So those are the ways.
Which buttons do you say we should hold down?
Okay. Windows. You know where Alt is on your go to.
Yes.
You know where your space bar ALT.
Yeah.
To your left. The next
Yes.
button beside it is a Windows key.
Window, yes.
So when you hold that window, then there is a shift key, normal shift.
Yeah.
Where there's enter, there's shift here. Or beside that window, you know where Z is, there's an arrow up. Where letter Z is, there's an arrow. That's a shift.
Yes.
Yeah. So then shift, then S for sugar, S for Sarah, S.
That's four buttons to click down.
No, that's 3 buttons.
3.
Windows, Shift, S.
Oh, okay. So I don't need the ALT.
No, you don't need the ALT.
Oh, I found it. I can see it.
So that's the way you do. That's the way to do it. So that's why I said tomorrow. Those are things that you can use. You don't need any rigorous tools. Those are things to use and you can get it. Yeah. So that's it. Any other question before we end the class? Sorry, I'm over the class. I don't like to do this. Sorry, I'm over the class. So any question? In the absence of no question? No question? Anybody talking? So I believe you all understand. So in the absence of no question, I want to say a wonderful thank you to every one of you for this night. Hope to see you tomorrow again at this very time. Thank you. I won't go beyond your time tomorrow. So sorry about tonight. Thank you all. Have a wonderful evening.
Thank you.
Thank
ma'am.
you.
very much.
Thank you. Good night.
Thank you. Good
Bye,
night.
everyone. Bye. Bye. That's my living room.